Hello, boys and girls. So I want to get into Scala a little bit to understand the protocol of the Constellation project. And on the weekend, I was reading a little bit into the code and started asking questions to the developers. And 2 weeks ago, I made this nice this nice Readme and a little bit more colorful and putting together the information. I wanted to extend on that and then make a video on the protocol I find here myself as well. And so I was thinking, actually, I should maybe take a step back and make another video targeted at a more, let's say, layman audience and explain what you should actually do or what you can expect if you look at the protocol code on GitHub, right? So in this video, I'm going to take a look at a few projects and show you the commonalities so you can see what makes for a protocol and you can judge it in a way. And for that, I also want to point out that half a year ago, no, even more, I already made a video on GitHub. Namely, I explained to you how you can download code and repository from GitHub and how you can fork it on your own profile, how you can edit Readme files, so you can even contribute to your favorite project without even being able to code, just make things prettier if you want. That's how I start usually with different open source stuff. And so there's a video, and you can check that out after this one. This is actually maybe a little bit less, how-to technical. This is just describing what you can look out for. So very shortly, I don't want to spend too much on these concepts because there are Wikipedia pages for yourself, and I know my viewership is super lazy. And they won't probably not do it. But if you're actually interested in that, I recommend, just reading the few sections of Wikipedia articles if you don't know these concepts, so you can follow along what people in your favorite projects are even talking about. Okay, and sorry for calling you lazy. It's true, but maybe it's a little bit harsh. So there is Git, which was created by Linus Torvalds, you could say the man behind Linux, and that's a version control system, meaning it's the main intention is to keep track of the evolution of some software package, right? You can if you write something, and it doesn't even have to be text files, it can be some sort of data, then you can for yourself save states and go back in time and see where you were like in the past and branch off. And it's also then useful to contribute, and there's a lot of technicalities of course behind it. The branches I was talking about, and they actually have to do with the data structure like a blockchain in a sense. It's you also have hashes, and they're put together, and also actually directed acyclic graph that I talked about a few days ago. But in any case, so there's Git, and then there is different companies and projects like GitHub. In this case, you can view that almost as a web application. It's a website where you can upload your folders that are already like initiated with the Git application, and can be used then to collaborate, because of course the GitHub platform in a sense has commonalities with a social network where you have profiles and people make changes, and you can have some tools to use Git. And I will not go into this in detail, but we will see in all the good protocol projects and open source projects in general, or generally projects where many people work together. And if you're very strict with yourself, even for yourself, hopefully, you can write unit tests for your for the modules and parts of your program, right? You write some code, and then you write code to test that code. That would be unit tests. And then continuous integration will also pop up, which is, I mean, you can put unit tests there and automate it, right? Whenever somebody makes a change and says, you know, that is code that should work and build and compile and should pass all tests, then this might be triggered automatically, and that's like in a nutshell continuous integration. I mean, there's of course more to all of this, and continuous integration is a concept, and there are so many tools that provide this thing. But we will see that. Okay, so far so good. So this is the home screen of GitHub. I'm already logged in here, right? So Nikolaj-K. And here, if you make an account, you see basically your own recent activity and people who interacted with you. So for example, I was discussing for the Constellation repository with the main devs some cryptography choices, and here I was with Alexandra doing some NOS stuff for Neo, and writing down notes for my book, on which I also should make a video in the near future. And then people following me apparently and looking what I do, and I know people starring my projects. And yeah, so actually let's go to my home page, let's say, like the profile page. Here you see your past activity. I mean, that's self-explanatory. You know, it says on December 25th I did stuff, and on December 13th I did even more. And I have here 25 repositories, like stuff I created, or maybe I just cloned or forked or copied. And then some pinned repositories, which just means I put them to the top to find them earlier, or maybe I'm proud of them, want to have quick access. So I will, like, before I go to crypto protocols, I will show you two of those repositories that I'm very familiar with, so you see what is common and what is not necessarily the same everywhere, and to get an idea of the structure. So if you look at this Turing complete smart contract, which I made a long video about, actually, here, I made a 1.5 hour video about it. It's a smart contract where you can upload a Turing machine in the form of a tape, and then it will execute it. So it's a smart contract on which you can compute any, let's say, numerical computation. And so the repository is really just a folder, right? It's a folder with stuff. And in this case, the folder holds only 3 files. And the one is the Readme file. So this is basically just the text form of what you see here, the description. And you can even edit files actually on GitHub directly also. So this would be just the plain text version, right, of the Readme file. Go back. And this is to explain what this repository is all about and how to use it, documentation. This is actually a link to the video. And I explain what it does, right? And then when you open a new folder, new repository on GitHub, then it will ask you, do you want to add a license? And usually you do that. I mean, for this small thing, it's not even worth it really, but you have some choices, MIT license, or you do your own for whatever reason. And it will ask you about a few things that you can put there by default. One would be a Readme file when you initiate the repository. Then this will basically be an empty text file, and then you start to fill it, and license, and then also gitignore, which we will see in other projects, which is a file that specifies the kind of stuff, for example, the kind of stuff that you don't always want to upload. Because, you know, if I, let's say, let's say I design some code and I make some flowcharts and make a picture out of it. And this is also happens to be in the repository, in my local folder about the code, but I don't want to upload it and update it to GitHub. Then you could specify this in the ignore file, the git ignore file, right? And then in this case, there's only one code file, which is .cs, so C#, which is one of the languages that you can use on Neo to compile to smart contracts. And that's a pretty neat 200 line code that I explained in depth in another video. Very well documented. Very good, Nikolaj. Well done. And then here you can look at the commits, which is the changes to this base. So for example, here, in this case, you know, I uploaded it. I made some small prettifications and corrections. And then I left it alone, and the last change I did to this repository was in last November. But you can also check out what actually changed here, right? This is stuff I explained also in the other video. So for example, here, I already made a link to the YouTube video explaining this smart contract. And then I made a screenshot of the YouTube screen thing and added this picture. So here you just see what I add. Here I add this PNG, and here I discovered, oh, I wrote length wrongly, and so I changed this, and then it will say, well, you know, this sentence changed to this sentence. So you can see, you can stalk what people change, and that's important if you want to read along with the code, you know. So we are going to do that in some of the more professional looking repositories in a second. And then let's look, just to get more structure, at another project I did here. There was the lab control graphical user interface. About 2 years ago, I was working for a lab which does circuit quantum electrodynamics. So basically trying to build quantum level microchips. And for them, I was writing this application in Python actually to have a tool to connect to all instruments and do the measurements for all the experiments from one spot, and not have to do necessarily use software that coming with all different measurement devices which are from different providers, and not use all graphical user interface, but all, you know, unite everything in one application. So you have this this window which pops up once you run the script, the Python script, and then you see a bunch of tabs. They all represent your measurement devices and different sorts of measurements with a bunch of configurations here, oscillator and digitizer and, you know, whatever, signal generator, laser. And then you would you choose, you know, oh, in this session I want to connect to this signal generator 31, click, and also to the vector network analyzer with the name ZNB, and connect. And then you would click connect, and then it would connect to all the measurements in the laboratory. So I also, of course, had to write all the drivers, so the tools to actually make the instruments do what they should. And here you can, you know, save and load all configurations. For example, the signal generator was supposed to measure at a frequency of 8 gigahertz, and then you have the pictures with the measurements results. So you would do a sweep, a measurement, and then would do that. Okay, I just explained this to you so you can see how this connects to the folder I will just show you in a second. Here, feedback window. What else is there? Measurement tabs. Okay, so far so good. And now this is I uploaded this picture on the internet on Imgur and included it in the README. So this is just the README here, right? There's a license. There's also git ignore. Let's see. I think I made this super short. Yeah, it just says that files of the ending .py-c, which is like intermediate compiled stuff, should not be uploaded, even though this was part of my program, but not necessary to use this on your own. And here I have the application programming interface, and I explain it in the README as you're supposed to, how to use it. Very nice with syntax highlighting and a bunch of links, and so that's all pretty and well. Here's the main file, and if you take a look at that, that starts out by defining paths and then importing from these modules different things. Okay, and then runs the application. So this is the starting point, and this will reach into the module. VIP stands for Virtual Instrument Panel. I thought it was funny with that name. And so once you run it, it will go into the folder and go deeper and deeper. So this is this widget is the main window, and if that is called, then this will import even more and reach down into the folders, and you know, the code will collect itself and build stuff. And for example, then we have here in this widget folder the info dialog that we saw, or the plots window with the graphics when the measurement is done. And then in the interface, I have tabs for different things, right? And the measurement tab and whatever it should do. And then here, auxiliary functions, which we might also call utility or common functions. I say that because we will see something similar in the later repositories. And then the drivers, which was, you know, a pain in the ass to write those drivers, because every device is of course different. So there is, I don't know, I think some laser stuff, and then I was using class abstractions to do the driver, and all these drivers derive from a more general driver class. Is this here too? Yeah, I even called it parent, which has all the functionality that I expect. So it can take the settings and write them to the instrument, and okay. So far so well. Now let's go to protocol repositories. So this was of course very like physics oriented, but now let's check out the mother of all cryptos, Bitcoin, right? So this is the user Bitcoin, and maintained by Bitcoin Core. And here you see the main repository. Here you kind of roughly see the activity. It's relative, of course. Let's say they would stop working on it, then this line would fall flat and nothing would happen anymore. And then they have a bunch of supporting libraries. Here you have who is part of the, let's say, developer group, but a lot of people are private, so you don't always see everything. So this has not much meaning. And it's actually very, very short, like very small, let's say, profile, because there are only 4 repositories. But the main thing is here Bitcoin implementation in C++. And if you look at the Satoshi Nakamoto paper, he was also using C++, and so I suppose that's how that derives, apart from arguable speedups. Okay, so here we are in the Bitcoin repository. This is there's a bunch of much more than we saw before, but there's also Readme. Then there's also a git ignore. Let's take a look actually. So you see there's a lot of stuff that they specified how the git system should act here. Here's something about tests, documentation tools, and then the README, and this also has integrated some information about, let's say, tests, right? The compilation of this code to an app. if it's passed or if everything is okay. Short explanation what it is, and this is actually pretty short, but of course they link to a bunch of other explanatory content. Okay, and typically most, like, unless you start coding yourself with this, a lot of the files and stuff will just be some configuration files, some numbers, or some scripts, like here this .shell script that automate different stuff that you don't want to do on your own all the time when you interact with the code or build it. So what do we have here? So again, also like many of the folders, subfolders here might not be very rich or deep. What we definitely want to look out for is the SRC, the source folder. So that's where the bulk of the stuff is. And you can also see here when people contributed, and not surprisingly, the source folder is where the action is happening. So 3 hours ago, an hour ago, somebody changed something here, and then maybe this folder 9 months ago, it's just something that doesn't, like, it's not really part of the development process, right? And then there's tests. Let's take a short look. Utilities, and that's nice. See, they also have Readme files for subfolders, how you can actually use this. You see they have some tests, actually not in C++, but in Python. Okay, and then here, this Python utility tools, because it's nice to script stuff together. The docs, wow, there's a bunch of, like, MD is just a markdown file with text that you don't necessarily want to execute in any fashion. And so yeah, they have their documentation. It's just not in the README on the in the root of the folder. Manual and release notes. So that's proper here. Different versions. So, but again, this is, I just need to read the name. I don't need to go into the detail if you want to get an impression of the whole project. So let's go into the source. And I suppose the Bitcoin protocol sets some standard because, as we will see later, a lot of folders from protocols have the same sort of structure and even names, and most of it will derive, I suppose, from Bitcoin, really, because it's copied from there. So what do we have here? We have the cryptography stuff, and I suppose, to be honest, like among all the crypto projects and shitcoins, usually nowadays they are more like, I have feeling they're more like web developers than cryptographers doing this kind of things. Nothing against web developers. That's like a hard job, but coming from a mathematical background, of course, cryptography is interesting, and you just know that people who discuss cryptography proper, they will rather sit in the Bitcoin project than any of the more lighthearted let's do a protocol forks or other funky ideas. But there are, of course, exceptions to that. The Bitcoin core team, there are some interesting discussions if you follow along with that. So there is a bunch of hash functions, and I have several videos actually on hash functions. SHA-2, which version of this, namely a squared version, Bitcoin uses for various things, and obviously a bunch of other things. And cryptography with Bitcoin, this doesn't just mean hashing, but it's also signature stuff, and it goes deep. Okay, and then we have that, and then we have the LevelDB database. If I'm not confused, the LevelDB database is actually one of the offsprings of Google project initially. In the open source world, there's a lot of Google projects. I think TensorFlow is Google as well as like this is the open source artificial intelligence tool. And then scripts, tests, then here on the root even wallet implementation, some tools, RPC, like communicating internet stuff, also database file, and .h and .cpp is all C++. Tests. So in the wallet file, they have tests for the wallet. So for the wallet, they test the cryptography, and so you can run that. And I suppose this goes into the continuous integration. And here you see some default numbers, and I suppose this is then tested on this. Boost. That's a C++ library that they seem to use. Although I actually thought that the Bitcoin implementation is super raw and doesn't use many libraries, but apparently they want to use some tool. As you see, I didn't dive deep into the Bitcoin code base because I'm interested in smart contracts and stuff, right? And at one point they decided to not go too far with smart contracts, and then some other folks like Vitalik were like, no, I want to have super strong facilities for smart contracts, and so I make my my super I don't want to diss anything, but you have to, like, cryptography and crypto projects is always trade-off, like security and scalability and usability. Okay, so let's not lose myself here. Go to wallet. So what else do we have here? Consensus, this is also very close to my heart. So consensus algorithm header file is quite short. Where is the corresponding CPP file? Transaction verification. I'm not going into any code really today. I'm mostly showing you the more nitty-gritty details, just so we can compare with other projects later in the video. So check transaction inputs. Merkle tree, this is data structure stuff. So Merkle tree, Merkle root, this is about the hash together data structure. Block witnesses. Okay, so I suppose benchmarking. They have also a benchmarking folder, which is nice, like checking if everything runs correctly and how quickly. I suppose since this is C++, it will outperform a lot of other protocols by far, for whatever you want to outperform, right? So I take that with a grain of salt, because not knowing all too much, bottleneck is often the way you structure things and how the network communicates, right? Not necessarily how fast, like apart from hashing, how fast a particular code executes. Okay, so that was Bitcoin. And to comparison, there is Bitcoin J, where they say, a library working with Bitcoin and also Java implementation of Bitcoin protocol. So, we talked about protocols before, and on this channel, and hopefully more in the future. And Bitcoin is like a protocol, right? It's like a recipe how to do things, like how to cook, and the language itself is not really so relevant. So I can describe to you how to bake a pie. I can do it in German and English, and a little bit of Italian maybe. It's not about the language, even though some languages might be better suited for music or others not. But it's not. In the end, it's about the algorithms. And so that's the not the C++, but Java implementation of the same protocol. And they have also here automated tests, and they have also wallet template, whatever that might mean. And here in the wallet even their own dedicated source. So I'm also not a Java programmer, even though I did some introductory Java at university. But here also, you know, wallet stuff and utility folder again. And let's go back to the root. And then, you know, the main folder inside the folder, like often called core, main, source in this case. I mean, there are slight distinctions, I suppose, between source and core, but because maybe you denote your main protocol as core and the main stuff, and then there are some libraries around it that you don't want. They are source code, but not in the core folder. But okay, that's semantics, and let's not get lost. Okay, so in the core these are just, you know, there are so many project files and configuration files and these kind of things, and I don't even know what that is. And a lot of the things are not really relevant for me. You know, with the mathematical approach, let's say I go in, I look for the consensus folder and maybe the cryptography to see what they use, and maybe to the wallet folder, maybe they have some links to nice pictures to see like what is their design perspective, or who is on it. And so here down, Bitcoin, core, source, and there's main and test. So they have this split. Let's go to test first. Java has these resource folders, and then, so wait a second. So this is Java org Bitcoin J. This slash just mean they have basically they have the test folder, and then they have Java folder, and in the Java folder is only the org folder, and the org folder is only this. And this is like Java-esque structuring of your project. And then, you know, inside Bitcoin J, 5 levels down, there's another folder again called Bitcoin J. Okay, and so here we have what I was expecting. So wallet, cryptography, another core folder, of course. Protocols, scripts, more testing. Let's check out crypto. So tests, private key test. So again, here is input, like even though this is Java and not Python that I showed you before, the statements look almost the same. I mean, here you have the semicolon at the end, but still here define classes of things that do this and that. Cryptography. For the tests, they have some hard-coded numbers, I suppose, or maybe some origin genesis stuff. Okay, and so that's that. That's Bitcoin in 2 variations even. And so what you can also do then is, let's go back to the repository here. So Bitcoin J, this is the username, right? And they have different projects, also only 4, funny enough. And if you go to the Bitcoin J implementation, then here you can see, like here you see the commits, right? So I had 6 commits on my smart contract thing, and here you see several like thousands commits, and you can also check out what did, like in the same fashion that I changed length to length, like when I rewrote it, here you can see what changes they make to the code. And if you want to keep track, like if you have 10 minutes each afternoon, you check out your favorite project and see what they're actually working on, and if they make any progress, and if you have some questions even, then here you can see all the edits. And you can all, like if you contribute to open source project like that, and you can also comment, right? So let's see here, there's some here's this Cradle thing that I said I don't know much about. Somebody maybe made the change to the gitignore file, right? And then another guy says, you know, maybe please change this, or that would be a good idea, so on and so forth. Yeah, so he makes some suggestions to improve that. And I can even, you know, I could go there and say, and ask question, hey, why, what does it even mean? Why do you include that? I would not do that. Something like that. And so I see my job in this project mostly to be annoying and make sure like they don't shoot themselves in the foot in any way that I can recognize, and they may be being inside their head and inside their thing what they don't see. So and then, like on a social network, there's the issues which you can open up, and there's people make basically threads and ask questions or find bugs or found bugs. And one note, because I've seen it in other crypto projects, if people work there, don't make basically an issue for a support question like, hey, on my I didn't have connect. Like there's a line to be drawn between you found a bug and you see an issue, and there might be a proper issue of the code, or you just have a very like personal question about your wallet and blah blah blah. So this is not like it's not ought to be like used like Stack Exchange. It's a place to improve the code. Or really to help improve the documentation, how to install it or something like that. That's my perspective anyway. So here are these sort of threads, right? So yeah, so people report of some issues they had. In this case, nobody responded. It's kind of sad. Let's go back in time. So here people make enhancement proposals so they can detect it. So okay, let's go to the issue number 641. So some people, this guy, right, he tried to build it to make the app, I suppose, and then he posts what the error messages he gets, right, and then he answered his own issue. Let's see if we have a time here. Yeah, so like apparently 50 minutes later he found out what the problem was, or at least he has a hint and adds that to that. So I'm maybe a little bit overcritical, but issues that are not responded to by the people who maintain the code, that's a sad story in my opinion. But of course it's work, right? You have to hire people who do that. Okay. Yeah, and finally, this is also quite crucial. If you look at the project like that, right, you can look at insights, which is helpful, and then contributors, and then you see the activity over time and who did what, right? So here you see, like, this started 2011, like they started with the Bitcoin implementation, just a few years after Bitcoin idea was released. And then you see how much people do and who did most. Okay, so I sort of take back what I said before, but because now I realize this guy is kind of the main contributor to this repository. At least in this time, like in the time before, like between 2013 and 2015, he did a lot of work there. He added like, I don't know, 100,000 lines. And then at one point he kind of dropped out of the project, or maybe got another username, and after that this guy kind of took over, right? And you can also here specify, like, let's see, between 2000 and in the last year 2017 2018 who did the like most. So, and you see, okay, the other guy of course is removed now, he didn't do anything, and this guy did a lot of things, and then he made a lot of contribution in February. And we can, stock this down if we wanted to. We can go to this guy, Andreas Schildbach, and here we see, here in February, right? He did a lot of stuff with Bitcoin shit. Let's go there. And here we can see that in February, where he was doing so much, was for the Bitcoin wallet repository doing changes. And then here we can look at the commits here and maybe scroll back in time a little bit. So April, let's check older. Still April. He was very active here. And whenever you make a change to the code, then that would show up here. And like people who are super diligent, they will actually, before they commit, like the idea is actually that in a nice project, the commits should tell a story. They should be committed in a way that if you read along the commits, that you can actually understand what happened and why things happened. And so some people sometimes they work on their own local desktop, and then they would like restructure their changes and commit them in a sequence that makes sense as a story to how the code they develop. But that's of course like people who want really make sure that other people in the future can read it and get into the code. Okay, so you saw I kind of stalked down what this guy did, and he was the only contributor to the Bitcoin wallet this time. So much for Bitcoin. He even made an own user. He made an own user for own project for just this wallet, and this is the only thing that's here. Interesting. Okay, so now Ethereum, right? Just 3-4 years ago. A lot of inspiration, of course, from Bitcoin. A lot more permissions regarding smart contract and what you want to do, and of course, as we all know, it led to a lot of the ICO madness, and that's the main application here. And nevertheless, a lot of the repository structure will look actually pretty much the same as Bitcoin, right? So they have a lot, like, since there are a lot of developers and a lot of good people, they have a lot of different things and like libraries around it. And you see this wipe-up, I think it's a Python-esque smart contract language that would compile to the Ethereum virtual machine. Binary. And what we are looking for is the Ethereum implementation. So they have actually an Ethereum J as well, the Java implementation of Ethereum, and Python implementation of the Ethereum virtual machine. And I look actually for Ethereum Go. Yeah, here, which I suppose is the main implementation. So Ethereum repository. Here again we see crypto. Wallet at the end. Well, that's a big folder. I don't have a wallet folder as such, but I'm pretty sure down there somewhere they have one. Contracts. So right, I think Bitcoin didn't have anything like that. For example, like not a dedicated folder to that. Consensus. Let's take a look. So they import a bunch of things at once. So I'm not Go. I'm not a Go hacker. So I would have to look into that, how this compares, for example, to the class implementations that we saw with Bitcoin. And then, okay, what's in core then? Types virtual machine. Let's check out the virtual machine. Common, like, can be utility stuff. Calculate memory size. That's some type tool to read out for location. Oh, gas. Some type specification, unsigned integer, so and so many bits and bytes, call gas, bunch of small files. Okay, so that's good. Let's see like a bunch of issues, insights. Who is actually writing this code? So here is similar story, right? So people do, and then other people take over. Let's see this here. Oh yeah, this guy. Nonsense. So you can see here what happens. You see what his interests are. He's like That looks to me like a GitHub power user, like extra fancy info. He does Ethereum obviously, but I'm not sure if that's all he does. He's part. Here you can see part of organizations which basically often associated with rights to do this and that in the code base. Okay, that's all Ethereum stuff. What is this? Decentralized cloud messaging. So I could, get myself lost here, but let's not dwell on it too long. Okay, so I will speed up here a little bit. New project. Here, okay, new, like, I said the names core, source, main, neo, like new, just the name of the folder itself would be classical. And then, here we have the same thing. Cryptography, smart contract, virtual machine, wallets, right? So keep here wallets. This is in C#. Classes, and then different helper, utility, all the same thing. Type stuff. Okay, so you see, it's obvious the commonality, right? And then let's actually compare then that with later the city of Zion group. So okay, so here we see, I happen to know these guys actually. So they are from city of Zion, started to contribute a lot lately to the main Neo source code. And now if we look to the city of Zion username, which is the open source developer group, the Western developer group, let's say, then why I want to point it out is because the city of Zion also started to do an implementation of Neo itself. So they also have a Neo Sharp implementation, but they were like, there are a lot of good people there who thought, we can do it a little bit more concise, compact, and start adding features and stuff. So this has more support for tests and is much more modular. It implements the same protocol, but is implemented differently, even if this language is the same. So a bunch of test folders, source, but of course also quite to the point, virtual machine, wallet folder, and so on and so forth. And then Cardano, or import output, is one of the companies related to that. I know the Daedalus, it's the wallet they have, so they will not have this. This is a whole nice user interface wallet, and they call their main project SL Settlement Layer for the smart contracts. But in the end, it's the same thing, right? So DB, like with Neo, probably we would also see that. Let's check that out. It's been a while since I checked it out, but okay, there's consensus core. But there's also, I think, also level DB, which is often used. And if you do a blockchain protocol, you don't have to use the same database, but people just copy from what works best, and mostly from Bitcoin. Okay, and let's go back because I don't rant too much here. Let's just take a look at that. Jenny's comments. So here also same folders, crypto, let's say, tests inside crypto, and this is HS Haskell. Okay, this is just importing other stuff. So let's go deeper. Encryption, random script. Script is a hash, I think, or a toolbox for keys. Okay, before I say anything wrong, the Haskell code, of course, looks quite different than C type code, like Java's C-ish, let's say, at least compared to Haskell. So that's that. And then finally, the constellation. And this structure is, again, this very similar. So you have the Readme, and then a bunch of build scripts and gitignore, license, Readme, and then a nice thing is there's a bunch of, for example, Docker tools to pass the installation process and ship it in a package form. And I hope once there are more developers on board, then these in my experience, developers love wrapping things in Docker packages and making installation easier. Once they get hurt from having to spend 3 hours with some stupid installation, then they wrap it in the Docker, and then they are super proud. And it's cute. It's cute to see this the network kind of people. I don't know, working on these kind of things. So there's more scripts. I think that's shell scripts, right? There's also Docker stuff, and then I didn't touch upon environments like .NET, and I didn't say anything about virtual machines like the Java virtual machine. So there's a bunch of support, and there's continuous integration related things. And if you go into the source, and let's skip the tests because I'm already at 1 hour almost. Then here we have, that's not where I wanted to get in actually. Okay. So I landed in the continuous integration IT folder, but I actually want to go into main and into the Scala. So that's where I wanted to go in. So here is then the consensus stuff. Crypto. Right. Different conventions. And I am not a Scala hacker, but I'm looking very much forward to understand that and to see the DAG implementation. So lots of work for me in the future. And if we look at the commits, for example, then there's me doing Readme stuff. And one thing I want to point out, so this is the master branch, right? This is in the whole video I was always looking at the most surface branch, right? And if you do it, like for example in the Constellation repository, then you actually code on a more developer-oriented, I don't want to say experimental, but more like tried out branch where you push your own commits and changes, and then when the decision is made to make a release version, then the developer branch is merged to the master branch, and then you would see all the changes and the upgrade to the next version. But often to check out the project and what the project is doing, you want to go to the developer branch, and in this case it's called dev. And there's a refactoring going on. So for example, here is some refactoring. When I started to do more professional coding, I was a little bit confused, but refactoring just means a sort of clean up and rewriting. So I suppose some more specific type was introduced, and then Preston went through all the folders which are tied to this metric structure object and doing rewrite, and you're removing things and you're adding things, I suppose, right? And also, what I've seen so far here in this project, the issues are used for planning a lot also. There are a bunch of web apps and tools where you basically plan out who is going to do what and what is the milestone and so on. So there's actually developer stuff, and I don't want to spend too much time on that, and go back to the consensus stuff. But just to give you an overview, this is how you check out protocol repositories. Sorry for the long video again, but I hope you learned something and know how to get a better grip on who's doing what and to follow developments and judge if a project is valid or not. Okay, so with that, I leave you. If you want to do use GitHub a little bit more yourself, then go to that video and you can see how to fork projects and so on and so forth. So, okay, take care.